We can also use graphs of functions to solve equations or inequalities graphically. So, for example, we can compare the values of two functions, f and g, visually by drawing their graphs. The points at which the graphs intersect are the points where the values of the two functions are equal. So the solution of the equation f of x equals g of x are just the values of x at which the two graphs intersect. And then the points at which the graph of g is higher than the graph of f are the points where the value of g are greater than the values of f. So basically you're solving this equation g of x inequality g of x greater than or equals to f of x. So let's see what that means with an example. So let's solve this equation and these two inequalities graphically. So if I let f of x be the left-hand side, 2x squared plus 3, this is just a parabola. It's a parabola opening up, and the vertex is at 0, 3. Remember the vertex, the x-coordinate is negative b over 2a, but b in our case is 0 because it's not there. And then the y value of the vertex is going to be f of 0. And when I plug in 0 in the function, I get 3. So the vertex of this parabola is at 0, 3. And then, there's no x-intercepts for this. So this is if you remember, the discriminant is negative, so that means it has complex solutions. So it doesn't intersect the x-axis. So it's a parabola like this. It does not intersect the x-axis. So I have the parabola, and then 5x plus 6, my g of x, is just the line 5x plus 6. It's the y-intercept is 6, and then the slope is 5, so it's a line like this. So this is 6 right here. I have the parabola with the vertex at 3. So when you graph the parabola, and then you graph the line as well, the points of intersection, that's where f of x equals g of x. So f of x equals g of x. The solution to this is the point where it intersects. So it intersects at the point x equals negative 0.5 and at the point x equals 3. So if you want to solve equations graphically, you just graph and see, you just graph the two functions. You let the left-hand side be one function and you let the right-hand side be a function. You graph them and you see for what x values the graphs of those two functions intersect. Now, if I wanted to solve the inequality 2x squared plus 3 less than or equal to 5x, I'm actually trying to solve f of x less than or equal to g of x. So basically, looking at the function f of x right here, I want to see where is the function smaller than g of x. So where is the graph of the function f below the function g, the graph of function g. So you see that if I look on this piece, this is f, is above g. And then if I look on this piece, g, which is the blue one, is above f. So f of x, in this case, on this interval, f of x is below g of x. So then we say that f of x is less than or equal to g of x between negative 0.5 and 3, between the two intersection points. And then if I am interested in solving f of x greater than g of x, notice that for this one, we had f of x less than or equal to g of x, so that's why we included the endpoints, because at the endpoints, the two functions are equal. So we're including the two endpoints. Now, when I'm interested in f of x greater than g of x, so I want to see where the function f is above, the graph is above the function g. Well, I can see if I look in here, I see that this is f and this is g. The function f is above the graph of g. In between, the function f is below, so that's not going to be part of the answer. And then after 3, the function f again is above the function g. So we say that the solution to the inequality f of x greater than g of x is negative infinity to negative 0.5 and then 3 to infinity. The reason we put parentheses at negative 0.5 and at 3 is because it's strictly greater. If it was greater than or equal, then we'd include the endpoints for this one and that one. All right, so let's do one practice. And then that will be it for lecture 3, I guess. So let's look at this function. We can tell that it's a function. It passes the vertical line test. It's a piecewise defined function. We don't have the expression, the algebraic expression for it, but we don't need it to solve these questions. So what is f of negative 4? Well, negative 4 is right here. So negative 4, the y value, f at negative 4 is 3, 4, 5. What about f of 0? When x is 0, the graph is also 0. The y value is 0. F at 2, 1, 2. F at 2 is 3. And f at 4 is 2. Find the domain and range using interval notation. Well, the domain, again, if I was to box this up into between two vertical lines, the domain will be negative 4, and there is a value, a y value for negative 4. So I'm going to include negative 4, and then all the way there is value, there is y value, there is y value. At 2, there is y value, and then at 4. And there's also a y value for 4, so the domain will be negative 4 to 4, including those. What about the range? So if I was to box up the graph between two horizontal lines, it will be between this line and this line. And this line will be 0, and this line is 5. And it includes 0 and it includes 5. So the range is 0 to positive 5. To find the values for which g of x equals 4, this should be f of x. F of x, this function is f. F of x equals 4, well, just draw a horizontal line that goes through the value 4, and where it intersects, that's where we're gonna have that f of x is 4. So 1, 2, 3, 4. So I'm gonna draw a horizontal line through 4, and this is where it intersects with the graph. So it's gonna be for this x value, which is negative 1, which is negative 2, and also for this x value, which is, let's say, approximately 3.5. So then find the values x, so it intersects at x equals negative 2 and at x equals 3.5. And then choose the right values for which f of x less than or equal to 1. So similarly, for f of x less than or equal to 1, I can draw a horizontal line at f of x equals 1. F of x equals 1. So this is 1 and this was 4. And the graph is below this f of x equals 1, this horizontal line x equals 1. So between what values does that happen? Well, it looks like between almost negative 1 and then something, 1 point something. So if you look at your choices, the one that is almost negative 1 into something above 3 is this one. So between those two values, between those two x values, the graph is less than or equal to 1. And the fact that it's equal to 1 is taken into account that we put brackets. Find the net change between x equals 1 and x equals 2. The net change is this change in y value. So it's just the numerator of a slope. So the net change is just going to be, if this one was x1 and this one x2, the net change is the y value. So it will be f of x2 minus f of x1. This is your y2 minus y1. And x2 is 2, so it will be f of 2 minus f of negative 1. What was f of 2? F of 2 was 3. And then f of negative 1, let's see what's f of negative 1. F of negative 1 looks like 2. So the answer is 1. The net change is 1. Okay, and one last question. Where is the function increasing or decreasing? Okay, so looking from left to right on your entire domain, we're going to see what happens to the y value as we let x go through the whole domain. So the y value starts here at 5, and then it decreases, it decreases, it decreases, it decreases until here. So on the interval -4 to 0, so let's see, we're going to respond that right here. On -4 to 0, on this interval, -4 to 0, the function is increasing. Once it hits this value right here, the function, it increases. So between the values of x from 0 to 2, the function is increasing. So on 0 to 2, the function, this arrow up was going to mean increasing. Okay? And then from 2 to 4, the function decreases. On 2 to 4, the function decreases, arrow down. Alright, so if you have the graph of a function, so even if you don't have the equations that govern that relationship, you can still get a lot of information from the graph. You can tell what the domain is, you can tell what the range is, you can read off function values, you can see where the function is increasing, decreasing, local min and local max. So that's another thing that, let's do J. Let's find the local min, and let's just do local min in here. So the local minimum in here, there's only one. It happens right here. The local min is going to be 0, happens at 0. And its value is 0. So it happens at what x value, and its value is what y value is that. So since this right here is 0, 0, the min happens at 0 and it happens to be 0. Which makes sense because the range is from 0 to 5, so the minimum value should be 0. Alright, so you will practice more with local min and max in the homework. I think that's it for section 2.3.